Let's look at a couple different applications, word problems that we can apply to setting up algebraic expressions and solving equations. So first off, let's make just a little list of a couple keywords to watch for that mean different operations. This is certainly not that long of a list. There's many, many more, but let's just make a list of a few. So addition, words like increase, or more than, or just some of the obvious ones like add, sum, things like that would mean that we're going to add. Subtraction, things like decrease, we're decreasing something, or one thing is less than another. Difference, if it's the difference between things. For multiplication, the word of often means multiplication, like percentage of something, or by, talking about like the dimensions of a room, 12 by 20. If we multiply those, we get the area. So sometimes by, so of, by, and then there's some others like product, things like that. Division, kind of a mathy word, quotient. But anytime we're talking about like splitting something into different parts, let's just say that's split into parts. So it might not even say that, but just if we can think of a problem like that. Per is a big one. So figuring out like miles per hour. You take the miles divided by however many hours. That gets you the speed. And then an equal sign, if we see the word like is or any form of the word is, that is where we typically put an equal sign. So let's do some where we just have to rewrite the statement into an algebraic statement, into math symbols. So 12 more than a number is 5. So 12 more, so this is going to be plus. So I'm just going to write 12 right under. 12 plus a number, we could use any variable here. I'll just do n for number, equals 5, is 5. So 12 plus n equals 5. I'm going to put or. Sometimes it makes sense to first do n plus 12 equals 5, because it's kind of like we have this number and then it's 12 more. So sometimes we think of the number first and then add 12 to that to get 5. And we're not going to solve these, we're just going to write them out. The difference between triple a number and 8 is 6. So the difference, so subtraction, between triple a number. So this is kind of a special one. Triple a number would mean 3 times. So I'm going to put 3n. We could put a time symbol between 3 and n, but 3n means multiplication. So the difference between 3n and 8, so 3n minus 8, and then there's that equal sign, is equals 6. And this is, sometimes it helps like put a line down the middle. We know that those are two different sides of the equation, so that splits it up. Okay, now the next one is very similar. Triple the difference between a number and 8. Very similar, but it's triple the difference. So if it's triple the difference, it's going to be 3 times whatever the difference is between a number and 8. So we need to do some parentheses here, because this is saying take the difference and then triple it. Is 6, equals 6. And one thing to watch for, it was on our list above, less than. I'm going to add an extra example here. Example. 5 less than a number. 5 less than a number. So, and it's just gonna, no equal sign here. 5 less than a number. So we might think in order that this would be 5 minus n. But it's actually, if it's 5 less, that's what's getting subtracted. So it's actually n minus 5. So I'm going to cross that 5 minus n out. Whenever it's less than, watch out for that. It's kind of like flipped around. Sometimes subtraction, different words with subtraction, we have to switch the order when we think about it. Oh, and it's going to come up in our next problem. So we'll use that. You're scaling down a window based on the perimeter of the window needing to be 160 inches. Okay, so I'm going to right away, I'm talking about a window, I'm going to draw this. If it's something I can draw, kind of like a geometry type thing, I'm going to draw it out. So perimeter means add all the way around. So if all the sides need to be 160, so all this, I'm going to just put a little P equals 160, the total perimeter. The longer side needs to be 16 inches less than double the width. So right here, 16 inches less than double the width. 16 less than double 2 times the width. But like we just talked about, less than, we kind of have to flip this around. So this longer side would actually be 2W minus 16. 16 less than double the width. And then that's it. Find the dimensions. Now, so there's nothing on the other side, but if we already called the longer side 2W minus 16, well then this bottom side would be W. Perimeter means at all the sides. So assuming we're talking about a rectangular window, top would be W, the other side would also be 2W minus 16. Okay, now you could just kind of add around on that image. I'll write this out, but if you can kind of just go around and skip the step I'm going to write right now, that's totally fine. But I'm going to write this out. So I've got 2W minus 16 plus W plus 2W minus 16 plus W. All those should add up to 160. Again, if you could just kind of add around on the rectangle, I've got 2, 3, 4, 5, 6 W's when I combine those. Minus 16 and minus 16 will be a minus 32 equals 160. Okay, so now we need to keep solving. So we'll add 32 to both sides. So 6W equals 192. Divide by 6 on both sides. And I'm going to get 32. 32 inches. Okay, now careful. We want to know the dimensions. So we have one side so far. We have 32 inches. So this is 32 inches. So to get the length, the longer side, we'll be doing 2 times 32 minus 16, which I believe is 48. I'm going to double check in my calculator just to be safe. Yep, 48. So the dimensions, and sometimes we write it like this. 32 inches by 48 inches. That little 2 marks is for inches. Okay, so next one. So our last problem. So the first one, you know, kind of geometry-ish type problem. Draw it out, that helps. Next one is a type of problem where we've got different parts. So there's a lot of different types of problems you might come across where, or situations where we have different parts that have different, like, kind of like ratios, but can't quite use a ratio because maybe we're not just comparing two things, we've got more going on. So let's do this one first, and I'll talk about some other exam types you might come across. It'll be similar to this. So you own a small business in a summer vacation area and hope to increase your profit next year and need to start planning. In the past years, the second quarter typically has profit of double the first, and then the third, I'm going to do some underlining here. So the second has a profit double the first quarter, and then the third has a profit of 4 times the first, and then the fourth typically has the profit the same as the first. So it's, you know, first is like January, February, March, slow, then business starts picking up, then it's busy, really busy in the summer, and then it slows down again. So the desired profit for the whole year is $110,000. What is the profit for each quarter? Okay, so I'm going to kind of label my parts. I've got my first quarter, my second, my third, and my fourth. So I'm going to kind of make columns here and showing that I want this to total up to $110,000. So like in this case, there's 4 quarters. I need 4 parts to it, like 4 algebraic statements for each quarter. So well, the first part that we're given, the second quarter typically has a profit double the first. So under second, I'm going to put double 2 times the first. I'm going to use an X. You can use a different letter if you want, but I'm going to use 2x. The third typically has a profit 4 times the first, so that one's 4 times, so 4x. And the fourth has the same as the first. So I'm just going to put 1x, just an x there. Now, be careful, notice how we didn't put anything under first, and sometimes that happens where we forget the thing that we're basing everything off of. In this case, though, we need to also include an x for the first quarter. Okay, so when we add all these up, we should get our 110,000. So, key is when we got these different parts, make sure you have 1, 2, 3, 4 algebraic statements if we're talking about 4 quarters. So x, 2x, 4x, and x, that's 8x. So then when we divide by 8, so 110,000 divided by 8 is 13,750. Okay, so that's going to represent the profit that we won in the first quarter, and actually the fourth as well. Okay, so then the second, just kind of go down here, we want to double that, 27,500. Okay, so that's I'm going to put 2x next to that, and then the 4x is going to be 55,000. Okay, so that is my third quarter. And if we want to check this, we can add those up. Just make sure to count the 13,750 twice, because that's for the first and for the fourth. Okay, so other problems you might see like this with different parts. I think, like a tank. This tank can hold this much. This tank can hold 50 gallons more. You'd have to have x plus 50, things like that. So when we're breaking things into parts. So kind of do this labeling up top, that helps.